Okay, for what I'm going to talk about is just kind of the basic vocabulary that we need for this week in the data mining class. What that's going to boil down to is I'm going to talk about support, confidence, and accuracy. And then in a later video, I'll show how we use that for the PRISM algorithm. Before we do that, there's just a little bit of background because we're talking about rules. And the vocabulary we have for a rule is that a rule ends up being an if-then statement. And so we have if some condition, which we call the antecedent, then what we say is the consequent is going to be something. And so the consequent, depending on what kind of rule we're dealing with, can be two different things. If it's a classification rule, then the consequent will be something then class equals and then whatever the value of the class is. That's if it's a classification rule. If it's an association rule, then it doesn't have to have that form. It can just be feature equals value of feature. So what's written on the screen here is what we'll see with classification rules, which is what PRISM does. PRISM is a algorithm that we can use for classification. The notes explain it's a bottom-up approach. It starts with the classes instead of the features. Starting with the features is called a top-down approach. So the first thing we want to deal with, if I can ever figure out how to actually go to the next slide. Look, I did it. Hooray for me. So the first thing we want to deal with here is the idea of a support. And the notion of support is a pretty general one. In data mining, people talk about the support of a rule, and they also talk about just the support of an antecedent. So there's two ways to look at it. First, in the slides here, we have the idea of the support of a rule. So a synonym for support is cover. The textbook author tends to use cover, but I kind of think support is a little bit more common. But it's not like a 90-10 kind of thing. It's more like 60-40. But because what the textbook author uses is not the most common, I want to give you guys the other picture, so that's why I'm using the word cover more. But what it boils down to is you look at the whole rule, and then you compare it to the data set, and then you just say, okay, well, how many instances are actually valid for that rule? So in this example from the slides, we have one with the weather data. If outlook equals sunny, then play is equal to no. So there's two parts to it. The antecedent part, we want to know, okay, so which ones have sunny? And so we can just look at them. And we see there's four of them. So there's four in play, four instances in play according to the antecedent. But then we have to look at the other part. And this is a classification rule because it's dealing with the class variable play right here. If the rule had been, if outlook equals sunny, then windy equals false, that would be an association rule because windy is not the class variable. So what we're dealing with now is the consequent, play is equal to no. And so we want to see, okay, out of the ones where outlook is equal to sunny, which ones have play is equal to no? And so we end up finding three of them. 1, 2, 3. And so what we say is that's the cover of the rule. This rule has cover 3, or this rule has support 3. Another term that your book uses for this, and they give it the symbol of little p, is that it's the number of positive examples. So out of the data set, how many instances are true for the rule? How many fall into what the rule says? And that's actually what we need for PRISM. So the positive examples of if outlook equals sunny, then play equals no, there's 3 of them. So aside from the support, we can talk about not the support of the whole rule, but then just the support of the antecedent. And so what we do there, if we have the same rule that we had on the previous slide, if outlook equals sunny, then play is equal to no, instead of worrying about what the consequent is, we just look at the first part. We don't care if this rule actually works or not. We just want to know which instances are in play when we're dealing with this rule. So outlook sunny, outlook sunny. Well, we've already seen this on the previous slide that we get these 4 underlined. So now we don't care if play is yes or no in this case. We just care that there's 4 instances that actually match what's going on in the antecedent. And so we can say that's the cover or support of the antecedent, or we can use the abbreviation of a little t, which is what your book uses. So we would say if outlook equals sunny has support 4, or we would say that it has t is equal to 4. So the last definition we need here, we've already seen the idea of support, and we've already seen the idea of positive examples, or we've seen, if you want to look at it the other way, we've seen the support of a rule, and we've seen the support of an antecedent. So both of those are counts of instances, and so that's important enough that it's worth writing down in what little space we have. That support of a rule or of an antecedent, it's always going to be an integer because it's a number of instances. So this last one that we're dealing with, the confidence, it's different. It's a ratio of two numbers, or it's a percentage, whichever way you want to look at it. Two ways of saying the same thing. And it depends on the two things we've already defined. And so, like it says here, it's the positive examples divided by the support. And so what we have, the book says it's the positive examples, they call that little p. And then the support of the antecedent, they call that t. And so if we deal with that, because we're dealing with the positive examples, it depends on the whole rule, the antecedent and the consequent. And then this part just depends on the antecedent. So if we stick with the same example, if outlook is equal to sunny, then play is equal to no. Then we look, okay, we need to know what t is, so we're dealing there with the antecedent. So which ones have a sunny outlook, and that's not me. Then what we have, we get 4 of those. So we get t is equal to 4. So without looking at the consequent, we already know what t is. We know what the denominator is. And then which ones have play is equal to no. And so this is just putting together what we've done on the previous 2 slides. So we have 3 of them. So we can say the confidence of this rule is 3/4, or we can say that the confidence of this rule, if we want to divide it out, is 0.75, or we can say the confidence of this rule is 75%. Either one of these 3 is a perfectly valid way of saying this. So what we'll do in the next video is we'll look at the PRISM algorithm now that we have these things down. A lot of the homework questions, I think 3/4 of them, or 0.75 or 75%, ask you just what's the support of an antecedent, what's the support of a rule, what's the confidence. So at this point, just by looking at this part, you should be able to do some of the homework. You need to listen to the next video or watch it to be able to do the first homework question.